Okay, so up until now, we have spent most of our time focusing on lines written in slope y-intercept form, and that is y equals mx plus b, or y equals the rate of change x plus the initial value. In our last lesson, we were introduced to a new way of writing a line, which is called standard form, which was ax plus by equals c. So basically, those two forms can be used to represent the same line. They're just rearrangements of each other. So we can use our what we know about rearranging equations or solving inverse operations to rearrange lines to go back and forth between slope y-intercept form and standard form. And up until now, we have looked at how to graph lines in the slope y-intercept form, but we want to also have some strategies for graphing lines in standard form in an efficient manner. So that's what I'm going to talk to you about today. So we're going to use the x and y intercept method to graph lines that are written in standard form. And before we do that, I want to go over with you just a little bit about the x and y intercepts so that we can use what we know about them to help us graph them. So when we're graphing lines in standard form, it's often easiest to use the x and y intercept method. So first of all, let's talk about the x and y intercepts. So I'm going to start off with talking about the x-intercept. So here I have a line. I put it on a Cartesian plane. And you can see that if I'm looking at the x-intercept, basically where does the line hit the x-axis? It happens at the point 4, 0. Okay, so it hits it right there. The coordinates of that point are 4, 0. And you'll notice that at the x-intercept, the y-coordinate of the point is equal to 0. And that will be true no matter where the x-intercept occurs. So if the x-intercept happened to occur here, the y-coordinate would be 0 because the point would be 1, 0. If it happened over here, then the x-intercept would be negative 3, 0. The y-coordinate would still be 0 because we don't go up and down on the y at all when we're talking about the x-intercept. We just talk about the x. So x-intercepts occur when that y-coordinate of the point is 0. So it'll always be in the form a number, comma, 0, where y equals 0. Okay, we can talk about the x or the y-coordinate in a similar manner. The y-intercept in a similar manner. So the y-intercept is where the line hits the y-axis, the vertical axis. In this case, for this line, the y-intercept is this point right here. It's the point 0, 2. And again, if we look at the coordinates here, for the y-intercept, we have a y-coordinate of our graph, but our x-coordinate will be 0. And again, it doesn't matter where we start it. Like I could start it down here at negative 4. If this was my y-intercept, the point would be 0, negative 4. So that x-coordinate of the point of your y-intercept will always be 0. Okay? So to summarize, for the x-intercept, it always occurs when the y equals 0. For the y-intercept, it always occurs when x equals 0. So what we can do is we can take this idea and we can use it to help us actually graph lines that are written in standard form. And I'm going to show you how to do that. So here we have the line 2x plus 4y equals 8. So it is written in standard form. I've got my x's and my y's on my left side of the equation, my constant on the right. I could rearrange it if I wanted to put it into slope y-intercept form. But let's just keep it as it is and see if we can graph it in an efficient manner. So what we can do is we can look at this equation and we can see if we can figure out what the x-intercept is and what the y-intercept is. So we know, like I just showed you, that the x-intercept always occurs when y equals 0. So if I take y equals 0 and plug it into this equation, I can figure out the x value that goes with it. So I'm going to start by writing out my equation, 2x plus 4y equals 8. I'm going to plug in my 0 for my y. So I get 2x plus 4 times 0 equals 8. Well, we know that 4 times 0 is 0. So that leaves me with 2x equals 8. I'm going to divide both sides by 2. So I get x is equal to 4. Okay? So I know then that when y equals 0, my x is equal to 4. So that's going to give me the point 4, 0. and I can plot that on my axis. So at the point 4, 0, I put my x-intercept, and you can see that it crosses my x-axis at the point 4, 0. I can do the exact same thing. This time I'm going to find the y-intercept. So I know that the y-intercept occurs when x equals 0. So if I take my equation and I sub in x equals 0, then I can figure out what the y value is that goes with it. So I've got 2x plus 4y equals 8. I'm going to sub in x equals 0 for my x value. 2 times 0 plus 4y equals 8. Well, 2 times 0 is nothing. It disappears, goes away. All I'm left with is my 4y. So I get 4y equals 8. I divide both sides by 4 to get the y by itself, which means that y must equal 2. So when the x value is equal to 0, the y value of my point is going to be equal to 2. So I'm going to plot that point 0, 2 on my grid. And now I have 2 points. I have my x-intercept, I have my y-intercept, and I'm going to draw a line through those 2 points that is going to represent my line 2x plus 4y equals 8. Okay? So I can find my x-intercept by subbing in y equals 0, making that y term disappear and solving for x. And then I can find my y-intercept by plugging in x equals 0, making that x term disappear and solving for my y. I plot those 2 points on the grid and connect them with a nice long line to show what that line looks like. Okay? I do want to point out, I don't always write out this, I don't always write out this much when I'm using, when I'm solving for my x and my y-intercept. Sometimes what I do is I jump right to this spot right here. So if I'm plugging in y equals 0, I know that's going to make this term disappear. So sometimes when I'm doing this a little bit quicker, I might just write 2x equals 8 because I know that my y term is going to disappear. And over here, I might not write out these lines here. I might just plug in my head x equals 0, which is going to make my x term disappear. So I know that my I'm just going to have 4y equals 8 left over, so I know that y is equal to 2. So sometimes when you get used to doing this a little bit more practice with it, you may skip a few of these steps up here just to get a really efficient way of finding the x and y intercept. Okay? So what I would like you to do is take a minute, see if, so you've got the equation here, negative 2x plus 8y equals negative 16. And I want you to take a minute to see if you can use, to find this, if you can find the y-intercept, find the x-intercept, and use them to just draw a quick sketch of what that line might look like. So take a minute, pause the video, and then come back and see the solution. Okay, so here's what I get. And I did it in, like I said, a little bit more efficient way of doing it. So I know I have so I have negative 2x plus 8y equals negative 16. When I find my x-intercept, I'm going to sub in y equals 0. So that means that my y term is going to disappear. And all I have left is negative 2x equals negative 16. So negative 2x equals negative 16. I'm going to divide both sides by negative 2 to get the x by itself. That leaves me with x is equal to 8. So on my x-axis, I'm going to put a point at x equals 8. Okay. Doing the same thing for the y, I'm going to find my y-intercept. I know this occurs when x equals 0. So I'm going to go up here. If I plug in x equals 0, this term is just going to disappear. So I'm left with 8y equals negative 16. I'm going to divide both sides by 8. So I get y is equal to negative 2. I plot my y-axis or my y-intercept onto my axes. And then I connect my 2 points with a nice long line that stretches all the way across my grid. I put arrows on both sides to show that it goes forever. And there is a graph of the line negative 2x plus 8y equals negative 16. And we'll try one more, and then you can practice some more on your own. So this time I want you to graph 3x minus 10y equals 15. So find the x-intercept, find the y-intercept, plot your points, and see what you get. Again, pause the video, try it on your own first, and then press play again so that you can check your work. Okay, and here is what I get. So to find my x-intercept, I'm going to sub in y equals 0. So that makes this term right here disappear. That leaves me with my 3x and my 15. So 3x equals 15. I want to get the x by itself, so I'm going to divide both sides by 3. So I get x is equal to 5. I'm going to plot that on my axis. So I get x is equal to 5 right here. And to get my y-intercept, I'm going to sub in x equals 0. That makes this term go here. I'm left with negative 10y. Don't forget to include that negative in front of that 10 because I haven't gotten rid of that part. I've only gotten rid of this x part of the term. So I get negative 10y equals 15. I'm going to divide both sides by negative 10. So I get y is equal to negative 1.5. I'm going to estimate where that is on my graph, right about there. I've got my x-intercept, my y-intercept. I'm going to draw a nice long line connecting the two. Again, arrows on both sides, and you can see now what the graph of this linear relationship looks like. Okay? Okay, so now try a few on your own and see if you can figure this out.